Hello there, everyone. My name is Crazy Caleb, and today we're going to be taking a look at ladders. So this is the way the module looks, and what we're going to do is we're going to begin this module by selecting this round submit button up at the top. And what's going to happen after we submit this round submit button is it's going to reveal the first of three ladders that we're going to be working with some form of calculation to figure out. And what we're going to do is we're going to cut a series of rungs by selecting it to break it, which is the middle part of the ladder that connects the two vertical bits there. For each stage, break the correct rungs on each stage ladder and press the button to submit. So let's begin the module. And what we're going to do is we're going to have a ladder pop up here, and it's going to continue cycling these series of various colors present and repeating somewhere at some point. So we have the orange, gray, and if we wait a little bit, we have the orange, gray pop up again. The module's colors and abbreviations are red, orange, yellow, green, blue, cyan, purple, and gray. Gray, for the way that the abbreviations work, corresponds to alpha. It's spelled G-R-A-Y. So, and what we're going to do is, for the first stage, we're going to take a look at this little table here. And stage 1 corresponds to color sequencing. Each cell in the table below represents a color sequence for 3 adjacent rungs that can be read either upwards or downwards. So up, orange, green, or down, green, orange, etc., etc. What we're going to do is we're going to identify all applicable cells in the table based on the edge work that we have present, and only use one of the applicable sequences will be present on the actual first ladder. Let's take a look at what this table wants us to do. So for our rows, we need to determine the amount of batteries we have on the bottom. So let's take a look. We currently have 2 batteries present. So now what we're going to do is we're going to highlight each of the applicable columns if they happen to apply. So the first one is going to be 3 plus letters in the serial number. We do have actually 3 letters in the serial number, so this is going to be true. Next up, 3 plus numbers in the serial. We do have 3 numbers present, so that's going to be true. The serial number contains a vowel. No, whiskey is not a vowel, kilo is not a vowel, and golf is not a vowel. And lastly, serial number contains Charlie, Lima, 1, Mike, or Bravo. So let's take a look. Charlie, Lima, 1, Mike, or Bravo. None of those characters are present, so these are the only 2 columns that are going to apply. Alright, so now what we're going to do is we're going to look for a sequence that consists of cyan, gray. Remember, cyan, and gray. Gray corresponds to alpha, C corresponds to cyan, or green, red, and purple. So let's take a look here and see if we can find anything. And looking right here, green, red, purple is what we have present. So we are going to simply cut those 3 rungs, red, purple, if it comes back around. And note that once it does loop around, it actually does keep the rungs broken. And now that we have that little sequence of the only one applicable sequence present, and we've broken those rungs, we're going to press the submit button to advance to the second ladder. And just like that, the second ladder will pop up here in the middle. Now, for this one, stage 2 is going to be a series of it's going to be a binary conversion, and the second ladder's rung represents an 8-digit long binary number displayed using 2 colors. And a rung of a different color is present to distinguish the end/start of the number. So when read vertically, the higher rung is the more significant bit. So we're going to read from top to bottom, which we're going to correspond to left and right. However, what we need to do is we need to actually figure out which one corresponds to 1 and which one corresponds to 0, which color. So we're going to use the 2 colors that represent the binary numbers as rows / columns in the table below to identify which column represents 1. The other color will represent 0. And the rung of the third color will represent neither 1 nor 0, and it will never be broken. So what we have here is we have that single orange by itself. That's going to be our beginning / end, and we have red and gray as our colors present. Now it doesn't matter what colors we use as the column or row, because taking a look here, we have red and gray over here, which corresponds to gray. And if we do red and gray, it happens to be the exact same. You could do this with any table here. It is quite literally the exact same. So it doesn't matter what your row or column is, it will still give you the same answer. So what this means is that our gray will correspond to 1 and our red will be corresponding to 0. So what I'm going to do is we're going to start from the orange, and remember that red is going to correspond to 0 and gray corresponds to 1. So we're going to start from that orange, and we're going to go read this down vertically until we get to the end. So it should be 8 digits long. So we have 0 for red, 1 for gray, 0, 0, 1, 0, 0, 1. All right, and now that we have our 8 digits present, we're going to do a little bit of a, we're going to convert it to base 10 and adjust it according to the rule that matches the third color present on the ladder. Our third color happens to be orange, So we're going to do this little rule here. But first, let's convert it back into binary, from binary to base 10 rather. So for those of you who aren't familiar with how base 2 powers work and converting them to base 10, basically what we're going to be doing is we're going to be taking a look at each of the powers of 2. So we're going to start from left to right, being 2 to the power of 0, and then all the way up to 2 to the power of 7. So 2 to the power of 7, let's mark these as 7, 6, 5, 4, 3, 2, and 1, and then 0 as well. And what each of these powers equal to, so we have 2 to the power of 0 is going to be 1. That's going to be our way that we can get from odd to even. Then 2 to the power of 1 is simply 2. Then 2 to the power of 2 is simply 4. Then 2 to the power of 2 is simply 8. Then 16, if you happen to get the idea, you're simply doubling each digit present. Then 16, then we're going to go to 32 afterwards, then we're going to go to 64, and then lastly 128. All right. Let's reorganize all of this stuff to make sure that it lines underneath. So taking a look at the position that we have present on this little binary string here, we have 1s at the, so let's move all this stuff back a little bit, or just give it some space. So we have 1 at the second position from the left, which corresponds to 6, so 64. So we have 64 plus, moving along, we have 0, 0, then 1 at the third bit, or at the fifth bit rather. So 1, 2, 3, 4, 5 corresponds to 8. Then 0, 0, and then the last one being 1, so it's 2 to the power of 0 being 1, is 1. So we have 64 plus 8 plus 1, giving us 73. So 73 will be what this binary number is in base 10. And now what we're going to do is we're going to multiply this number by the number of ports present and use 2 if there are no ports present. So let's take a look at the number of ports we have. We have 3 ports. So here, so we're going to multiply this number, 73, by 3, being the number of ports that we have present on the palm. So 73 times this by 3 is 219. And if you have a pretty good idea of what we're going to be doing, if necessary, we're going to subtract this guy until from 256, or modulo it until it falls into the range of 0 to 25. And now we're going to convert the adjusted number, 219, back into binary. And within the 8 rungs that represented the initial number, break the rungs that correspond to 1s in the adjusted number. So we would start at the orange, and then we would do the bits from left to right, or from going top down. And we would cut the ones that correspond to 1. So let's convert 219 back into binary. Now the simple way that I do this is I simply take 219 and I simply keep subtracting values that are able to fit into 219, or we simply subtract that are lower, the numbers that are lower than what we have present. So 219, can we subtract 128 from 219? We can, so that's going to count as a 1 for that bit. Next up, 64 can go into 91, so that's a minus 64. So that's going to be a 1. 32 cannot go into 27, so that's a 0. 16 can go into 27, so minus 16. That's going to be a 1. Then we have 8. 8 can go into 11. It's going to be a 1. Then 4 cannot go into 3. 2 can go into 3, so minus 2. And then 1 can go into 1, as you would expect. Oops, something here. It was this 0 right there. All right, and now that we have everything here, so this is going to be our new converted binary, we're simply going to cut the rungs that correspond to the 1s. So we're going to cut rungs 1, 2, 4, 5, and 7, 8. So starting from the orange, we're going to cut 1, 2. So 1, 2, skipping 3, 4, 5, skipping 6, 7, 8. We're going to hit the submit button, and we're going to move on to the third stage. And just like that, it's good. Note that not everything submits when you do the last stage. It submits, and the answer will be correct if the next letter happens to pop up. That means you've done something right. So moving on to the next stage, and the last stage actually, what we're going to do is we're going to do an alphabetical sequencing. And what we're going to do is the third letter cycle is 7 rungs long. And it's going to have a series of unique colors present. And what we want to do is we need to make sure, we need to figure out first what color we're actually missing. And already from what I can see, the color that we're actually missing here is red. So we're going to mark this as red from later on. We're going to note that down. Red is missing. So what we're going to do is we're going to first locate the word first locate the word in the word bank below whose first letter matches the fourth character of the serial number. So let's take a look here. So the fourth character of the serial number is a kilo, so we're going to correspond this to the first letter being keratin, and this will be the word that we're going to do some stuff with. Keratin. Let's zoom in on this guy. All right. If the fourth character of the serial number is an X-ray, we're going to use Yankee instead. Just let you know that. All right. So now what we're going to do is we're going to place the X's in the column headers here, below with the letters of this word, keeping their order in the word. Keeping their order in the word. We're going to locate the applicable row and the process the columns in alphabetical order according to the word's letters. So simply what we're going to be doing is we're going to take each of these letters in keratin, and what we're simply going to do is I'm going to simply put a number below each of these guys based off of alphabetical order. So looking here, alpha comes first. That's going to be number 1. Next up, echo is going to be number 2. Then continuing on, India is number 3. Kilo is number 4. November is number 5. Romeo is number 6, and then Tango is number 7. Yes, 7. All right. And now what we're going to do is we're going to take a look at the row that corresponds to the absent color of the ladder, which we said red was missing. So we're going to use red for this guy here. And what we're going to do is we're going to locate the applicable row and the process of the columns in the alphabetical order. So we're going to take a look at the position with the earliest letter in alphabetical order, which corresponds to alpha, and that happens to be in the 4th position. So we're going to correspond to the 4th position. And what we're going to do is we're going to create a sequence of 7 colors, and that gives us the order of which we're going to break these in the rungs. So looking here, and remember the abbreviations for each of these colors, red being Romeo, orange being Oscar, Yankee being yellow, green being green, which is golf, blue being Bravo, cyan being Charlie, purple being Papa, and gray being Alpha. So let's go back down here. So since Alpha was first, we're going to take a look at the 4th column, which is the position that it's in, and Papa, or purple, is going to be the first color that we're going to hit. Next up, Echo is the 2nd column. That corresponds to blue. India is the 6th column, which is an Oscar, so orange. Next up, Kilo is the 1st, so we're going to take a look at the Yankee, so yellow. Then November is going to be the next one, so we're going to take a look at column 7, which is a golf, or green. Then Romeo is the next one, so we're going to take a look at the 3rd column, which is an alpha, so gray. And lastly, for number 7, we're going to take a look at the 5th column, which is Tango, which is the last position in the actual word, and we're going to hit Charlie, so cyan. And this is the final order that we're going to submit into the module, pressing and breaking the rungs in the specific order corresponding to each specific color. So we're going to hit purple, then blue, then orange, then yellow, waiting for it to come back around, then green, then gray, then cyan. And just like that, we're going to hit the submit button. A little smooth beat will play, and just like that, the module solves. Let's take a look at one final example. I'm actually not going to load this this one up because the conditions for the color sequencing are going to actually be the exact same. I'd rather get some different conditions and see what we can do. But yeah, the module is pretty straightforward. It definitely starts off easy and it goes into some more trickier stuff. I'd say probably the binary conversion is probably the trickier of the two last stages, and obviously the color sequencing is pretty darn easy. Let's take a look at one final example here. So let's pop up this last ladders, get some different edge work. I don't want to save that mission. Just to make sure that I am recording as I am. Alrighty. So to begin the module, we're going to hit the submit button to get our first ladder. And let's take a look at the edge work that we have present on the bottom. So how many batteries do we have present? We have 2 batteries again. And let's take a look at the serial number. We have greater than 3 letters in the serial number. We have 3 plus batteries, 3 plus letters rather. But in this case, we don't have 3 numbers, 3 or more numbers. Do we have a vowel present? No, we do not. And do we have any of these characters, Charlie, Lima 1, Mike, or Bravo? we do actually have a 1 present in the serial number, so this column is actually going to be true. So now what we're going to be doing is we're going to be looking for either cyan, cyan, gray, or red, cyan, gray. And taking a look from what I already see here, we do have a cyan, cyan, gray present, so we're going to cut these, or we're going to break those 3 rungs right there. So it doesn't matter what the order is as long as those 3 are broken, and we're going to hit the submit button and move us on to the next stage. No strike was given, so that means we're doing good so far. All right. Next up for the binary conversion here, we have, taking a look here, we have gray and blue as our 2 colors, and yellow is the 3rd color on its own. So we have gray and blue, so gray and blue. Blue is going to be our 1s, and grays is going to be our 0s. So we're going to start at yellow. So waiting for it to come back around. Gray 0, blue 1. So we have 0, 1, 1, 0, 0, 0, 1, 1. And that's going to be our binary conversion. Now, I know binary off the top of my head, and I would advise you guys to learn a little bit of binary. It's pretty easy to learn as long as you understand how bases work, base 2. So let's actually calculate this guy back into base 10. So this position corresponds to 128, then we go down to 64, so we're going to add 64. Then we're going to add the next one being 32. Then our last 2 is going to be 2 and 1, so that's going to be pretty simple. Plus 2 plus 1, giving us a total of 99 for our current, our first number. And then what we're going to do is with the yellow, because that's the 3rd color we have here, we're going to take the number's digital root and cube the result. So we're going to take the digital root being 9 plus 9, so 9 plus 9. For those of you who aren't familiar with digital root is simply adding all of the numbers present in a number until you're left with 1 remaining digit. So we have 9 plus 9 here. It's not 1 remaining digit left. We have 18 here. So we're going to simply add 1 plus 8 now, giving us 9. And 9 will be our remaining number. So now what we're going to do is we're simply going to cube 9, which, for those of you who aren't familiar with how cubing works, 9 normally would be squared is how you refer to 9 to the power of 2. Cube is how you refer to 9 to the power of 3. So we're simply going to multiply 9 times 9 times 9, giving us 729. Now, if this is necessary, we're going to subtract 256 until it falls between 0 to 255, which in this case happens to be greater than 256, so we're going to modulo this guy, mod 256, giving us 217. And now we're going to convert this guy back into binary, and we're going to submit that into the module. So 217 minus 128 being our 7th power, to 2 to the 7th power, so that's going to be true. The next step, we're going to subtract 64. We're going to skip over 32. We're going to have 16 in there. Then we're going to add 8, and then we're going to skip over 4 and 2, and then adding 1. And this is what we're going to submit into binary. So let's start from the yellow. So we're going to do 1, 1, skipping that one. 1, 1, 0, 0, 1. Submit button. And moving on to the next stage. So our fourth character of the serial number is a Quebec in this case, which is a qualifier. So now what we're going to do is let's figure out the color that we do not have present in the ladder for this last one. And looking around, we have red, we have... It looks like the color we're missing is yellow, and I'm not seeing a yellow present anywhere, so this is the row that we're going to be using. Yellow is our absent color. And now, as we did before, we're gonna figuring out the alphanumeric positions of each of these letters present, and we're simply just gonna put the position, the order of them rather, down below each of them. So alpha obviously is our 1. Then next up, the next letter to come in alphabetical order would be foxtrot, so it's gonna be our 2. Then it's gonna be India, which is number 3. Then it's Lima, which is number 4. Then out of Quebec, uniform, and Yankee, Quebec is going to be first, so that's going to be number 5. Then uniform, so number 6. And lastly, Yankee is going to be number 7. And this is the columns that we're going to look at. So we're going to look at column 3 first, which corresponds to blue. We're going to look at column 6 and then 5. 6 being green, 5 being purple. Then next up we have column 4. Which coincidentally is number 4, which is cyan. Next up, we have column 1, which is position 5, which is orange. Column number 6 is going to be column 2, which is alpha, which is gray. And then column 7, which is going to be a red as our last color, if you haven't guessed that already. So now we're going to break those rungs in the specific order. So we're going to start with blue, green, purple. Blue, waiting for green to come back around. Green, purple. Cyan, cyan, orange. Gray, red. And once everything's said and done, the module solves. As always, thank you guys for watching. Remember to stay crazy, stay cool, and I'll see you guys in the next one. Bye-bye.